Pwa Pilipinas would like to thank the following sponsors: Amazon Web Services, Apper.ph, Community Partners, Algo Filipino, Omnicotion, Angel Hack, React.js Philippines, Google Developer Student Club AMA Computer College Caloocan, Angular Philippines, Phil IT Org, Computer Professionals Union. Maraming salamat!
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers so you can focus on what matters most to your business.
Pwa Pilipinas would like to thank the following sponsors: Amazon Web Services, Apper.ph, Community Partners, Algo Filipino, Omniquotient, Angel Hack, React.js Philippines, Google Developer Student Club AMA Computer College Caloocan, Angular Philippines, Phil IT Org, Computer Professionals Union. Maraming salamat!
I'm Rafael Kisumbing.
I'm Grace.
Representing the R users group of the Philippines.
I'm the CEO and founder of Filter.
Very excited to share AWS UG Buildhurst Plus. I'm a volunteer and co-organizer.
Very important that you have the knowledge of what's the culture that you really want to put in place.
For us, it's really about finding really great, world-class digital and e-commerce talent. The Philippines has been a very good place to be.
Technology is actually a great equalizer. The community's inspiration is that, there's a safe space.
The fact that you joined, that's already a big step.
Having the platform of a very clear vision and values and a mission of the business and empowering people to make decisions.
This will not be the only episode that you will see. We will have a lot more. I'd also like to thank our co-presenter, AWS and AWS SICLab.
Pwa Pilipinas would like to thank the following sponsors: Amazon Web Services, Apper.ph, Community Partners, Algo Filipino, Omniquotient, Angel Hack, React.js Philippines, Google Developer Student Club AMA Computer College Caloocan, Angular Philippines, Phil IT Org, Computer Professionals Union. Maraming salamat!
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers so you can focus on what matters most to your business.
I'm Rafael Kisumbing.
I'm Grace.
Representing the R users group of the Philippines.
I'm the CEO and founder of Filter.
Very excited to share AWS UG BuildHurst Plus. I'm a volunteer and co-organizer.
Very important that you have the knowledge of what's the culture that you really want to put in place.
For us, it's really about finding really great, world-class digital and e-commerce talent. The Philippines has been a very good place to be.
Technology is actually a great equalizer. The community's inspiration is that, there's a safe space.
The fact that you joined, that's already a big step.
Having the platform of a very clear vision and values and a mission of the business and empowering people to make decisions.
This will not be the only episode that you will see. We will have a lot more. I'd also like to thank our co-presenter, AWS and AWS CLI.
PWA Pilipinas would like to thank the following sponsors: Amazon Web Services, Apper.ph, community partners, Algo Filipino, Omniquotient, Angel Hack, React.js Philippines, Google Developer Student Club AMA Computer College Caloocan, Angular Philippines, Phil IT Org, Computer Professionals Union. Maraming salamat!
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers so you can focus on what matters most to your business.
I'm Rafael Kisumbing.
I'm Grace.
Representing the R users group of the Philippines.
I'm the CEO and founder of Filter.
Very excited to share AWS UG Build Hers Plus. I'm a volunteer and co-organizer.
Very important that you have the knowledge of what's the culture that you really want to put in place.
For us, it's really about finding really great, world-class digital and e-commerce talent. The Philippines has been a very good place to be.
Technology is actually a great equalizer. The community's inspiration is that, there's a safe space.
The fact that you joined, that's already a big step.
Having the platform of a very clear vision and values and a mission of the business and empowering people to make decisions.
This will not be the only episode that you will see. We will have a lot more. I'd also like to thank our co-presenter, AWS and AWS Tech Lab.
Pwa Pilipinas would like to thank the following sponsors: Amazon Web Services, Apper.ph, Community Partners, Algo Filipino, Omniquotient, Angel Hack, React.js Philippines, Google Developer Student Club AMA Computer College Caloocan, Angular Philippines, Phil IT Org, Computer Professionals Union. Maraming salamat!
Magandang gabi, everyone! I'm Alicito de Guzman, the community lead for Pwa Pilipinas, and some of my teammates will join me in a few, but first, I will be introducing to you our organization, Pwa Pilipinas. So, before we begin the talk, Pwa Pilipinas is the community for progressive web app makers, designers, and users here in the Philippines. Our mission is to introduce and nurture progressive web apps development and adoption in the Philippines and beyond by fostering a community for subject matter experts, enthusiasts, adopters, and developers of the platform, and by providing resources and engagements to stimulate the interest in progressive web apps. Because our vision is that progressive web apps will be adopted widely here in the country. So what's the progressive web apps I'm talking about? Well, progressive web apps are your web applications, but are supercharged with native app-like features like having the ability to be installed, to work offline, and work across all devices and form factors. And with that, thank you for 2 amazing years of supporting us here at Pwa Pilipinas, and we're entering our 3rd year, and we do hope that you join us on our future events and other initiatives. Okay, so given that we have our anniversary this August, recently we had our basics talk from August 1 to 15, where we had different topics. We also had we're also on our advanced part of our celebration that started from August 18 up until today, August 28, for the last. So if you missed all of those, you can still watch them at the Pwa Pilipinas app. You can visit it at app.pwapilipinas.org. It's also on Google Play and on the Microsoft Store if you're using Windows. And we're also on Facebook, Twitter, LinkedIn, and we also have a Discord server. Just visit bit.ly/pwa-discord. And yeah, we do have our Facebook page, our Facebook group, Twitter, LinkedIn, Instagram, our email at hi@pwapilipinas.org. We also have our website at pwapilipinas.org. Okay, so since this is really exciting, so let's put our speaker now on stage. But first, I'll be introducing him. So our speaker for tonight is Rob Richardson. He is a software craftsmanship. He's a software craftsman, building web properties in ASP.NET and Node, React, and Vue. He is also a Microsoft MVP, a published author, frequent speaker at conferences, user groups, and community events, and a diligent teacher and student of high-quality software development. Without further ado, let's welcome mabuhay at maligayang pagbabalik sa Pilipinas, Rob.
Hi! Magandang umaga!
Magandang umaga din sa iyo. Kamusta naman?
I'm doing well. I was in the Philippines in the late 90s, and so it's fun to be able to jump back in and to enjoy the Philippines again. Thanks for having me at the group.
Yeah, the really great thing about this like lockdown is that we were able to invite speakers from like all over the world, and having you here is really a privilege. So thank you. So
it's kind of interesting. I get to speak tonight here in the Philippines, and I'm actually speaking this morning. So how did the day turn out?
Well, we started earlier with a workshop where we invited some beginners to learn a little bit about PWA, and they really enjoyed it. So
very nice.
And there's actually a talk earlier about SignalR, so they can learn how to integrate that with their web applications. So like
such an elegant technology. I like it.
Yeah, we really wanted to bring as much as possible here. Like since most people are at home, like right now is the time to really upskill.
Right.
So before we begin,
and it feels like the world is coming together. You know, we're all at home. We're all experiencing the same concern together. And so it's fun to be able to shrink the world a little bit.
Yeah. So how was your experience here during the Philippines?
It was so much fun. I was actually watching a Tagalog movie last night, and I was surprised. I didn't hear any manok in the background.
What movie was that, if it's okay to ask?
I don't remember. I didn't understand very much of it. It's been, 20 years since I've spoken Tagalog, but it was fun.
I see. Okay, so I guess we can begin now, so that we can even talk after.
Right? Oh, perfect.
Yeah.
So here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been that attendee trying to chase the speaker, looking for their talk, and it didn't work out very well for me either. That's why you can go to robrich.org and you can get both the slides and the code for this right now. Let's head off to robrich.org. Here's robrich.org, and here's containerized deployments for your SPA and API right here at Pwa Pilipinas. The slides and the code up on GitHub is available right now. You can grab these. I also tweeted these links. And so head off to robrich.org, click on presentations, and everything is available right now. While you're here at robrich.org, let's click on About Me. Thanks for the introduction. I'm a Microsoft MVP, a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver that completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Manila or wherever you're watching from, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I worked on the Gulp team in version 2 and version 3. That was a lot of fun. And what am I claim to fame? I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So yeah, there's my coveted .NET Rocks mug. So let's dig into containerized deployments for your SPA and API. We talked about this guy. A SPA and an API. So how do I deploy my app? That's usually the question that we ask. What gets us here? We have a SPA, we have a progressive web app, we have an API that powers it. And how do we deploy those pieces? What makes a progressive web app so exciting is that it's very interactive. We don't have page refreshes. We can cache data locally so that we can run faster, maybe even work offline depending on how our application needs data. And it runs anywhere. There's no install experience, no mechanism of distributing an MSI or trying to get packages installed. I click that install button, I get an icon on my home screen, and it's just really simple. That's wonderful. The backend then is an API. It can be a JSON API, a REST API, or it could be GraphQL or gRPC. And the beauty here is that this API doesn't have any UI associated with it, so I could consume it from anywhere. Maybe a mobile app or a watch app or something for a TV. This API could get consumed from anywhere. Now that's really cool. I've been able to separate my app into two pieces, one that purely serves data and one that allows for a really fast and elegant user experience. Separating that UI and the API, we get development and operational efficiency, which is wonderful. But we also get system complexity. We now have two pieces to manage instead of just one. So how do I deploy both pieces? Let's take a look at Docker, because Docker can be a really elegant solution here for deploying both pieces. Now, this is definitely not a Docker 101 talk, but let's level set a little bit and make sure that we understand what Docker is. Docker is an ecosystem around container virtualization. Containers are lightweight kernel virtualization. Instead of virtualizing the hardware, we virtualize the operating system. And then Docker is this suite of tools around it that makes creating these containers really easy. The analogy that I like here is, what is the difference between XML HTTP request and AJAX? Well, from a technical perspective, there's no difference at all. That's wonderful. From a user experience perspective, XML HTTP request powered the right-click menu in Outlook Web Access ages ago. AJAX, on the other hand, powers Google Maps and Facebook, and that app that you're going to build tomorrow. Docker didn't invent virtualization. Containers, C groups, jails, all of the namespaces, all of these existed previously. Docker made it easy for the rest of us to consume it, and that's what makes it so powerful. We're probably, as an industry, almost past this, but just in case, on the left is a traditional virtualization mechanism. On the right is Docker. On the left, we see that we have this operating system copied into each guest. On the right, we're virtualizing the operating system, not the hardware. And so we see that we only have the containers sitting on top of this hypervisor. This definitely isn't to scale, but on the left, we only got 3 virtual machines. On the right, we got 7 containers. We're already using our hardware much more efficiently. That's cool. Now, with a hypervisor, we still get that same sandboxed environment. The Docker hypervisor, like a traditional hypervisor, will give us a unique IP address and host name for each of the containers. They won't be able to reach into each other's processes. They're still isolated, sandboxed in the normal way. They'll connect through network connections to other containers if they need to. But we still get that level of isolation, but we have a whole lot more efficient use because we're virtualizing the operating system instead of the hardware. Containers. Containers virtualize the operating system. That means that the host operating system needs to be the same as the operating system in the container. So if I have a Linux container, I need to run it on a Linux host. If I have a Windows container, I need to run it on a Windows Server host. So what's missing? Well, what about GNOME and KDE? Can I run a KDE container on a GNOME host? Or even better, what about Red Hat and Ubuntu? Can I run an Ubuntu container on a Red Hat host? Yes, because I'm virtualizing the Linux kernel. And the Linux kernel is the same kernel underneath Red Hat and Ubuntu, underneath GNOME and KDE. So those pieces that are different from the Linux kernel will end up in the container. If I need Red Hat bits in my container, I'll have those Red Hat bits in the container running on top of any Linux host. Maybe it's Ubuntu, maybe it's Alpine, maybe it's Red Hat. Now, what else is missing? Well, what about Windows Desktop or Mac OS? I went to the docker.com homepage and I clicked on download and I downloaded something for my Mac. How do I do that? Well, when we look at developing for in our development environment, we'll probably do it like this on the left. Now on the right, we're working in production. We want to run as efficiently as possible. We want this host OS to be Windows if these are Windows containers. We want this host OS to be Linux if these are Linux containers. But in our development environment, here's my Windows laptop or my Mac OS. I'll have my Mac operating system. I'll have my hypervisor. In the case of Windows, it's Hyper-V. In the case of Mac, it's HyperKit. And then I'll install a Linux guest OS and the Docker hypervisor inside that. Now I can run my Linux containers inside of my Linux operating system. And that Linux operating system is a virtual machine on top of my Windows operating system. Now that's perfect. Now I can develop Linux containers on a non-Linux OS. Now, because this is a normal hypervisor, I could also install other guest VMs, and that works out pretty well too. So Docker. Docker is this mechanism of virtualizing the operating system instead of virtualizing the hardware. So we're using our system much more efficiently. But here's the other part, the Docker ecosystem. Now we have this methodology that starts with configuration as code, a Dockerfile, builds that into an image, and runs that image as a container on the Docker hypervisor. So here's our Dockerfile. It's configuration as code. It's all of the steps that we need to go from our source code to a running image or a running container. We'll take that Dockerfile and we will build it into an image. Now, the beauty of this image is it contains all of the pieces associated with our Docker container. And so it contains all the configuration files, all of the applications, everything's already installed. Now we can choose to share this image with others using Docker Hub or consume images from Docker Hub. And the beauty, unlike GitHub, where we would share our source code, with Docker Hub, we're sharing those compiled binary files. So if I pull an image from Docker Hub, I don't need to recompile it. It's already ready to go. I just need to start it. So we'll Docker build into an image, and then we'll Docker run to get that content running inside of a hypervisor. I can do similar things if I want to use lots of containers. So a Docker compose file might reference many Docker files or many images from Docker Hub. I'll build or pull all of those images, and I'll run all of them together in Kubernetes or in Docker Swarm to be able to get all of those containers running in concert. So that's the Docker ecosystem, that methodology of taking this configuration as code, this Docker file, building it into an image, and running it as a reusable container. So now let's come back to our PWA. We've got our PWA, and we've got our API. And how do we run them together? Well, outside of containers, we're probably going to do it like this. We have our SPA, our PWA, and inside that PWA framework, we probably are using something like a Webpack dev server. Now, the Webpack server can proxy certain content off to our API, and we'll do exactly that. The browser will hit the SPA all the time. And if the URL contains /API, then we'll forward that off to the backend API. If it doesn't contain API, then the SPA will be able to handle that, return the CSS or JavaScript or the index.html page. Locally, that's the way we'll build our application. Now let's see how to add it to containers. So let's go scaffold some content. I'm going to start off here. I've got a blank directory. make dir API, cd API, and let's say .NET new. Now, we could definitely open up Visual Studio and create a new project there. We could create a new project through Go or Java or Node. But in this case, let's do it through .NET. I'm going to say .NET new MVC. I'll say name is API and output into the current folder. Now, this is going to scaffold out a website that includes a model view controller. Actually, I probably should have grabbed a web API. Let me do that. Demo API. Yeah, let's go delete this website. And we will go generate a web API project. There we go. So now we have our API scaffolded out. It's got all of our controllers, and those will render out the various JSON pieces. And now let's go create our PWA. What did I call it? I called it Vue app. Now I'm going to choose to use Vue here, but we could definitely use Angular, React, Svelte, or others. The thing that I enjoy about Vue, though, is it starts to interview me and ask me questions about what features do I want. Now, I could definitely pick the defaults, but I'm going to manually select features. Let's turn on TypeScript. Let's turn on PWA support. We can include a router so that we can route on the client side to ensure that we can navigate between pages. We could include a Flux store like Vuex. We could include CSS preprocessors, so we're using SCSS, a linter and a formatter. We could include unit testing either with Mocha, with Chai, or with Jest, and end-to-end testing with Cypress. And once we've done this, then it will start to interview us and let us pick the particular features of each of these things that we want to do. So I'll break out of here, and I've already scaffolded out these pieces here in this folder right here, CLIs. So up on GitHub, we have this CLIs folder right here. Here's all of those projects. We have our Vue app, and it's got the normal content. The interesting thing here in this Vue app is we have all of these web components. Main will start us off and get us launched, and then app.vue will start to consume content. Now I created a new weather forecast component here. Here's that weather forecast component, and we're going to loop through all of the weather items, and we'll just render them off into my page. Now, I love this handlebars-like syntax. You might have used this in AngularJS or Angular or React. We're using it here in Vue just to loop through all of the weather items and write out their content. I'll also write an exception message if we have one. As we go reach out into the API, we'll go fetch from /API/weather forecast. And if that succeeded, we'll change our date format into a date and display the data. Or if it errors, we'll show the error. Here's our API. And the API, we've got a weather forecast controller that's built in. And so if we go to /API/weather forecast, then it will randomly generate some weather forecast data here. So I can now come in here to spot an API, cd to 0, and cd to net API. And I also say .NET watch run. I'll come back in here to the same folder, cd to Vue app, npm start. Actually, no, I think it's npm run watch. Let me go check my package JSON file. It is serve. npm run serve. Okay, so now I've got my Vue app running, and it has a Webpack dev server behind it. We did add a little bit of configuration here into our Webpack dev server to say anything with /API goes off to our .NET API. And then we've got our .NET API running here, listening to those requests. So let's come back here. Here's our API answering nicely. There's some data. And then we'll flip back to our Vue app. It's still building, it looks like. And that will show up on localhost 3000 once it finishes building. I think it's funny, as it discovers more modules, it iterates the second number as fast as it iterates the first number. Ooh, localhost 8080. It wasn't 3000. Okay, so let's go to localhost 8080. And here's our Vue app. I'm going to pull up the F12 developer tools, and we can watch this network request as it goes through. Now it loads the main page. There's that localhost. And then I'll filter by XHR only. And we now have this weather forecast call. The weather forecast call goes and reaches out to localhost 8080, and it gets back these weather data responses. So it reached into our API. Now that was perfect. We've got some weather data and everything is working great. Now we want to containerize this app. So let me actually stop this server and stop this server. And that's the end of our, actually, we didn't Dockerize the apps. Let's go do that. So I want to Dockerize these two apps. Now, my first step in Dockerizing an app is I'll come in here to my net API, and I will create a new file, and this is .dockerignore. Now, much like a .gitignore file, this is all the things that I don't want to include in my container. So all of my built assets, bin, obj, star.user, star.suo, the .vs folder, all of these things that will get built as part of my application. I also want to exclude content that is development specific. So app settings.development.json. And here inside properties, here's launch settings.json that also includes launch settings.json that also includes debugging information. It's all the details that I need to be able to debug my application. So now I've got all of these properties excluded. They won't show up in my app or in my container. And the next step is to build out that Dockerfile. Dockerfile. Now it's important that this be named Dockerfile and not Dockerfile.txt. So if you accidentally created it as a Dockerfile.txt, just come in here and remove the .txt. I have the Docker extension, so it shows me that I did it correctly because I have this nice whale icon. That's perfect. Inside of a Docker file, we will have 4 main verbs that we'll use: from, copy, run, and cmd. Now, these commands allow us to build up the various features of our container and talk about the things that we need to pull in. If you are familiar with from, copy, run, and cmd, you can probably read most Docker files. That's great. So from, we want to start on the shoulders of giants. So let's head off to Docker Hub and take a look at what we can build from. Now, this is a .NET API. So let's search for .NET. And we have now this meta repo that will talk about the various things that we can use to build our API. .NET runtime depths. This is everything that we need to be able to install .NET. .NET runtime includes the base runtime that allows us to run console applications. ASP.NET includes the web serving details. And on top of that is SDK, the build tools that will allow us to build a .NET app. Let's open up this one, and we'll use this to be able to build our container. Okay, so here's that base image that I need to use. Scrolling down a little bit, we can see that there is a that here's that 5.0 label that we grabbed. It's also tagged as latest. And that's built on top of Debian. But there's also an Alpine variant. Alpine is a very, very small Linux environment. And so here's 5.0 Alpine that will make our container that much smaller. Okay, back here, let's say from 5.0-Alpine. And now we have all of our build tools in place to be able to build our image, or to be able to build .NET apps. Next thing, we need to copy all the content. Now we want to copy all the content from this folder, so the folder where we run our Docker build command, into the current folder inside of our image. Now what is that current folder? Let's say work_dir is /src. Perfect. Now it's going to copy all of these things, with the exception of all of the things that we've chosen to ignore, into this current folder. Now, what do we need to do to run? Well, when we were here in the command line, we did a .NET watch run, which will start it up and rebuild it when anything happens. But here we want to do some other commands. So we'll say .NET restore, that will restore all of our libraries. Then we'll say .NET build, I'll build in release mode. Then we'll say .NET test, that will run all of our unit tests. Let's also build this in release mode just so that we don't accidentally have a debug version that we try to publish. And then .NET publish will publish in release mode to the dist folder. Now, this is not that unlike right-click publish inside Visual Studio, but we're doing it inside this build file to be able to get a very consistent result. Now, these are all the command line tools that we would use to get from our source code to this dist content, where we can publish that to a web server. Maybe that's IIS or Apache. Now here we want to run them as part of our build. So let's run this one. Let's run this one. Let's run this one. Run this one. And now we have that content in the dist folder. These will create new Docker layers for each of these commands. Then we want to start our app. So we'll say .NET and net API.dll. Now this is in the dist folder, so let's change our work_dir to /dist. And we do need to include some environment variables as well that tell both ASP.NET and both Docker and ASP.NET how to run. So we'll start our ASP.NET on port 5000, listening to all IP addresses, not just localhost. We'll tell it to run in production mode, which will do some additional optimizations. And we'll tell Docker that port 5000 is the one that we expect to connect on. Now this is perfect. We have our Dockerfile. This will work great, but there are a few things that we can clean up. We still have our source code and our build tools in our container, and we're restoring our libraries every time. So let's take this on. Let's say from, and back here in Docker Hub, we saw that there was an ASP.NET edition. So let's go look at that ASP.NET edition. Here is that one, mcr.microsoft.com. And we will then set this in place. And we will also use the Alpine variant. And now I have a second image that I've built. Here's my first image. I'll call this one my build server. My build server image. And this one will be my production runtime server image. And I'm using server in air quotes there. And now I'll change this to /app. And now I need to be able to copy the content. I'll copy from the dist folder into the current folder so that I can get all of this content into place. But this copy command currently says copy from out here. I want to copy from equals build. And so I'll name this one as build. Great. Now we don't have our source code in our production runtime container anymore. This one is pretty small. We can use this in and copy this one around really quickly. The other thing that we want to clean up is this. If we change any HTML files or any CSS files or any of our APIs, then we'll invalidate this layer of the Dockerfile. Then we'll run .NET restore, which will restore all of our NuGet packages. Now, that may take some time. So I really want to do it like this. I want to restore all my NuGet packages and then copy in everything. That way, if I change a C# file, I won't need to restore my dependencies. Now, I still do need a manifest, so let's copy in netapi.csproj into the current folder. Then I will restore my NuGet packages, then I'll copy in everything else, and then I'll run my build. Great, we have a build Dockerfile now that will run all of the steps that we need to be able to build this really lightweight API. Okay, so here I can come into my folder. I'm now in this spot. I have a Dockerfile right here, and I can say Docker build. I'll tag this on the way in, net API 0.1 dot. Now it's going to do all of the steps necessary to turn this from my source code into my Docker build file. And I really wish this wasn't blue text on a black background, but that's the font choice that they chose. And so now once we've got this built, we will have this image that we can use, and we can just Docker run this, and it will be able to launch our API. So it's doing each of those steps. It ran our NuGet restore, our .NET build, .NET test. We don't have any tests in this application, so of course all of our tests succeeded. .NET publish, and now we've got this image ready to go. Net API v 0.1. So we can say Docker run net API v 0.1, and I'm going to forward in some ports. So we said we're running on port 5000. So I'll do port 5000 to 5000. And now I've got that API running. Was not found. Oh, I misspoke here. This is a 3.1 app. So let's change this to 3.1. There we go. Now, if I were to Docker build this again, it would work out just fine. But I actually built this yesterday. So let's look at that. Docker run -p 5000 to 5000, net API, step 0. Okay, so there's our API, and it's running. It's listening on port 5000. So if I come here to my browser, I can come here to localhost 5000/API/weather forecast, and I get at my results. Perfect. So we've got our API inside Docker. Let's do the same thing with our Vue app. Now with our Vue app, we'll start out doing a similar thing. We'll create a new file, .docker ignore. Now we're in node land, so we'll ignore package lock.json. We'll ignore node modules. We could ignore other things, but that's probably good for now. And then our Dockerfile will be pretty simple. Dockerfile, we will say from back here on Docker Hub, let's go find a node base image. So let's say node. And here in node, we have an Alpine variant as well. So let's say, where is Alpine by itself? There it is. So let's say from node Alpine. Now we need to do our same steps, copy in everything to the current directory. Our current directory is /src. And then we will run npm install, run npm build, and that will build into the dist folder. And then we can create a new from node Alpine and copy in the content from the src/dist folder to our current folder. We need to do that from equals build, and we'll name this one as build. And then CMD, well, how are we starting it? Well, all of this is static content now. And if it's static content, then we don't need to run from a node one. We could just run from a static web server like Nginx. And if we're going to run it from Nginx, then instead of copying it to here, we'll copy it to var lib www root, I think, www. And now we have our content into place. And the Nginx actually includes the CMD. That's pretty cool. We still have our multi-stage build, but now we're running a static web server. Let's flip over to the results inside here and just go double check that I've done all those steps correctly. Ooh, I did optimize it to copy in the package JSON and install the dependencies. That will optimize us for a Docker build command. And we also need to copy in this nginx.conf. Now this nginx.conf, rather than returning a 404, will actually return the index.html in any other case. And that ensures that if you navigate to the about page or you just navigate to / that you'll be able to load that progressive web app. So we can do a similar thing. We'll come in here and we will, let me, cd into 0. Dockerfiles for each, cd into the Vue app, and I can say Docker build and tag this with the appropriate things. I already did that previously, so watching npm install is interesting. But let's just jump straight in. Here's that Vue app, step 0. So let's Docker run Vue app, step 0, and we will forward in the port. Which port did we forward in? 3000 to port 80. Okay, so now we have our API running here on port 5000. We have our progressive web app running here on port 3000. And if we come back here to localhost 3000, we correctly get our Vue app, but we get an exception here. We don't get our Vue details. Let's reload this page and take a look at it. Now we started off by loading localhost 3000, and then we did this weather forecast call to get to localhost 3000/API/weather forecast. Now, if we take this URL and we set it into our browser, what do we get at that place? Well, we get our homepage. That's what we told Nginx to do, because our API is not at 3000. Our API is at 5000. And that's the interesting dilemma that we have here. Let's stop this container. Stop this container. Oh, looks like we're going to have to do this. Docker container list. Docker container rm df6b, Docker container rm c6e, Docker container rm 695, and we've now stopped all of those containers. I'm going to take out the Kubernetes containers that I have also running, and now we have no containers running. Perfect. So that's usually where a lot of Docker 101 talks end, and we're just beginning. Now, how do we get started in containerizing both the progressive web app and the API together? Should we have one container or two containers? Should we deploy them to one domain or should we deploy them to two? Maybe my website goes to example.com and my API goes to api.example.com. How should we deploy both pieces? Well, I would suggest that it isn't just one choice, but rather we can kind of mix and match these. We could, on a single domain, deploy two containers or one container. And on subdomains, we could deploy two containers. We can't really deploy one container in two places, so this box doesn't apply. But we'll get to explore each of these three boxes, and that'll be great. So the magic question then, which one should I choose? I would argue that's not really the right question. Instead, the correct question is, why would I choose each one? In what scenarios is this the best fit? Let's take a look. So when we look at our progressive web app just with our regular thing, then we use the Webpack dev server to be able to hand requests from one place to another. In this first step, we're going to take one container, one domain. We're going to deploy all of the pieces into one big container. Both the SPA and the API live in this one container, and we can deploy that one container together. Now, how are we going to do that? Well, we'll add some static file hosting content to our API, and when we build our progressive web app, we will stick that in that public hosting folder. And so in development, we'll still use our Webpack dev server and proxy that off to our API. But when we build this in production, then we'll do this one container, one domain mechanism. So we looked at, let's close all of these. We looked here in the Dockerfiles for each, how we built up a Dockerfile for each of the Vue app and the .NET app. Let's now jump into this one container, one domain solution. And you notice that we don't have a Dockerfile in here. We also don't have a Dockerfile in here. Instead, we just have one big Dockerfile out here. Let's walk through this Dockerfile and take a look at what we've done here. Now, we build up our .NET app and we're publishing it into the dist folder. All of this looks standard. I named it build.net instead of build. And then we saw exactly how we built up the Vue app. We're doing that here as well. From Node Alpine, we're copying the package JSON, npm installing, switching over to our Vue app folder and are copying the rest of our Vue app and npm run build. Now here's where it gets interesting. We have a third stage that looks a lot like our .NET runtime stage, but it's going to copy in our content from .NET, and then it will also copy in our content from Vue into the app www root folder. We're copying it into that server's public folder. Now, here in the server's public folder, we also need to add a little bit of additional content. We need to use default files and use static files so that we make sure that we host those static details. There's also one more piece. In our Vue app, we had that nginx-conf that would always serve the index.html page as our home page for any of the client-side routes. And so we have this new SPA controller where we can give it the URLs that represent our client-side routes, and it will serve that index.html page. So now that we've got this, let's come into our next folder, cd to one container, one domain, and we can do a Docker build -t step one, or rather one container, one domain. And I've already done this, and I actually should have said Docker build -t, one container, one domain, and then the dot. That's our current folder where we're building. I've already done this. So we can see that we've got this container, SPA and API, one container, one domain. So let's do that. Docker run. I'll forward in port 3000 to port, actually this is, 3000 to port 5000. And I will run this, one container, one domain. And now that we've got this app running, we can see our .NET app is launched, and we will come back over here to localhost 3000. And we've got our app. And it's erroring. That's unexpected. It's doing it. It's got a 200 OK. We've got, oh, it's responding with the weather forecast. I don't think it's finished killing off our old container yet. Well, that's a demo fail. I think I also forwarding in port 3000 may have confused it. 045. Oh, actually, what port is my Dockerfile set up to listen on? Yep, that is port 5000. So I was incorrect. 045. Let's try starting that one more time and see if that will work. Actually, let's rebuild it. I am in that spot, so we will rebuild this app. Now, the cool part is that, oh, it just rebuilt it real fast. That's cool. Now let's run that. And then head back out to localhost 5000, because all the things are now running on port 5000. And there we go. Our initial request pulls down the HTML page. Here's that HTML. And our second request, here that weather forecast, goes and makes a request to /API/weather forecast. Both the progressive web app and the API are running on the same server. And so we get that weather data. That's perfect. Now we're able to solve it by packing both pieces into the same container. That was interesting. Let's come kill that container. Docker container rm3dd. Oh, I need to say -f. Okay. So we were able to pack both pieces into one container. Now this is great because we can easily deploy this content, both our PWA and our SPA, in one place. The downside is we can't scale those independently. The container is the unit of scale inside of Docker. And so if we want to scale up the number of web servers, we're going to scale up both the progressive web app and the backend API at the same time. Now, when would I choose this? If I was trying to deploy to a single shared hosting account, maybe Heroku or Azure Web Apps, where I didn't have an orchestrator like Docker Swarm or Kubernetes, then this would be the perfect place to host this that would send both pieces into one hosting account. I wouldn't need a separate hosting account for my front end and my back end. Next up, let's take a look at looking at two containers and two domains. Now, in this case, the browser is going to reach through the internet for example.com, www.example.com, and it will get my progressive web app. It can also reach through the internet to api.example.com to get at my backend API. So in this case, we'll have two different containers running on two different domains. Now, this is a little awkward because the browser needs to keep track of these two domains, and we specifically need this access control allow origin header. Now, this access control allow origin header is presented by the API server, and the browser uses it to know if its SPA front end can connect to this other backend API. So the API has a whitelist of allowed domains. The progressive web app has a hard-coded API domain. the progressive web app makes a regular AJAX request or maybe a fetch request, and the browser stops. The browser then creates an options request to that same URL and checks with the CORS headers to see if this access control allow origin header is present, and if this domain that it replied with is the current domain that this AJAX website is running on. If the browser notices that that CORS header is exactly this place, then the SPA will create the new request, the get or post or put request, and send that off to the server. So yes, it's making two requests for each thing. One to see if it has that options header, and then the options request to get the access control allow origin header, and then the next request to do the real content. So let's take a look at the Docker file that we need to be able to build this content. Here is the 2 containers 1 domain, or 2 containers 2 domain folder. Inside of our net API, we now have a Docker file, and this Docker file looks exactly like the Docker file that we built originally. This server has no concept that it's running cross-domain. Well, almost. We now have a new environment variable here that says, what is that cross-domain URL? Inside of our server, we do also have some setup details where we have to tell it, here's that CORS domain, and let me add this CORS header processing information to be able to send that detail. So here in my app, I also have an app setting that says, nope, that's not there. I'm injecting it here with this environment variable to be able to identify what that CORS domain is so that we can flip our app to be able to handle that. On the front end in our progressive web app, we now have a .env file that says, where is that base URL? Now, in the case of Vue, all environment variables must be prefixed with Vue_app. So we've got Vue app base URL. And if we pop open our component, we'll see that rather than just making the request to /API/weather forecast, we instead make the request to that base URL /API/weather forecast. And then here in our Docker file, we can see that we're doing nothing special here because we're injecting that environment variable in the build process. Now that makes sense because if we look back here at our diagram, the SPA, the progressive web app, is running here in the browser, not on the server. So we can't inject the environment variable here on the server. We need to inject the environment variable here into the static file running in the browser. So we must do that at build time. So we build up this, this container that has that environment variable baked in, and now we're ready to go. Now we have 2 separate web servers. So let's launch each of those. 2 containers, 2 domains. Let's run our backend API. Here's net API, 2 containers, 2 domains on port 5000. And we'll also run our progressive web app here on port 3000, going into Nginx on port 80. Okay, so now we've got our content ready to go. Let's come here to localhost 3000. We'll load our API, our SPA, and we can see it first makes the request to localhost 3000, gets back our web page, and then it makes a request to localhost 5000 to be able to get that weather forecast. And we get that response with the API details. That's perfect. So we went cross-domain, but we can also see here's that weather forecast. Oh, it actually blocked the, or hid the options request from us. But we can see that the server is responding with this access control allow origin header that includes localhost 3000. So we know that this API on localhost 5000 can consume the application on localhost 3000. Okay, so let's stop those two containers. Docker container rm e0c and 67d. Okay. So we're able to launch these two containers on two separate domains, and that worked out pretty well. On the upside, we can scale them separately now. We can optimize each piece as it evolves separately. On the downside, we needed to do all of this access control allow origin mayhem. That was kind of annoying, and we'll need to do that in each environment. To that end, our image is now hard-coded to that environment. For our API server, we were able to inject that as an environment variable, but for our progressive web app, we needed to put in that environment variable at build time, not at production runtime. So now we have different images for each deployment environment. That is a little bit awkward. And the course headers are really hard. I've spent a lot of time debugging all of the course headers, trying to make those URLs match. Two containers, two domains. This is great when my front-end team and my back-end team are very separate, when they agree on an API, but they don't really work differently from that. So next up, let's take a look at two containers, one domain. In two containers, one domain, we have our SPA on www.example.com, and we have our API on example.com/API. So there are two different containers running in two different places, and we'll have a reverse proxy in front of it that knows if it has a /API, that it should go this way, and if it doesn't, it should go this way. Now, the cool part is we've eliminated all of the course headers mayhem. The browser just connects to example.com. It doesn't connect to port 3000 and port 5000 or API dot and www dot. It just connects to that one domain. And this is the smarts that passes it on from one to the other. Now that's perfect. In production, we'll use a Kubernetes ingress controller to make this happen. In development, we'll use the same Webpack dev server mechanism that we did all along. In effect, that Webpack dev server is that reverse proxy saying if it needs to go to my API, I'll forward it on. And if not, then I'll forward it to my SPA build framework, Vue or React. So let's go take a look at that Dockerfile. Now here's this Dockerfile where we have two containers, one domain. We have our Vue Dockerfile, and we've seen this Dockerfile before. It's relatively simple, straightforward, no CORS details, no injecting environment variables. Here inside the .NET backend API, we have our Dockerfile, and that is also quite straightforward. We have no environment variable, no CORS headers details. In our startup, we don't have anything strange. We don't have use public or use shared folders or any CORS configuration. It's really simple. These Docker files are pretty much identical to the Docker files that we built at the beginning of this discussion. The magic happens here in this Kubernetes YAML file. So we'll have a deployment for our backend, and this specifies the number of replicas. It also specifies the details of how we start each container. Here's our net API, two containers, one domain. That's the image that we'll use. We'll forward in port 5000. We then have a Kubernetes service over the top of that will round robin across all of those instances. So it's going to listen on port 5000 and send that traffic out to port 5000. We have a similar deployment for our front end. In this case, we'll use two replicas and a similar service on our front end that listens on port 80 and forwards to port 80. And then here's the magic, this Kubernetes ingress. Now, the Kubernetes ingress is amazing at being able to take those particular details and forward them off to the service that it needs to. If I was running in this in production, I would add another host header so that this can resolve to that particular URL. But in this case, I'm just running locally, so I also disabled SSL. Now, if the path contains /API, then it will forward off to my .NET API service. And if the path doesn't, then it will forward off to my Progressive Web App service. So let's do that. Let's go into our two containers, one domain folder. And we could go in and build each of those containers, but I've already got it running. And so I'll say kubectl apply -f-k8s. Now, the beauty of applying this folder is it will go enumerate all of the files and spin up each of those pieces. kubectl get all, and I'll be able to see all the content. So it looks like we have our two front-end pods running, our one back-end pod. We have the two services, one for our front end, one for our back end. We have the two deployments ready to go. Kubectl get ingress. Let's take a look at our ingress. And so here our ingress is ready to go. And now if we come into localhost port 80, then we're able to get straight at our app. That's unexpected. My API or my ingress controller is misbehaving. Ah, demo fail. Well, that's unfortunate. Let me see if I can get at it this way. Nope, it's still going to be weird. It looks like I am not able to forward traffic into Minikube. Well, that's too bad. The beauty here, though, is that this mechanism will actually proxy traffic into the two containers using really interesting ways. This ingress controller is that reverse proxy that makes that decision to go between them. So that's really cool. Now we're able to scale our services independently. Our backend can scale up. In this case, we used one replica. Our front end can scale up differently. In this case, we used two containers. And we're able to scale each of those independently. We don't have any hard-coded URLs. We don't have any course headers. So it's a much simpler experience. On the downside, we do need a container orchestrator. In this case, we used Kubernetes. And so when would I use this? When I have Kubernetes available. Now, this probably, the complexity of Kubernetes probably requires many microservices. So I might want to have lots of different containers for all my different microservices, and then maybe either have the ingress controller reach out to each of those APIs, or maybe I have all of those APIs contained within an API gateway to be able to contain that content. A bonus round, a server-rendered SPA. Now, a server-rendered SPA is really interesting if I need search engine optimization. It'll take a first pass at rendering this content on the server, and then once it gets to the browser, the SPA, the Progressive Web App, will kick back up and continue re-rendering that content. Now, this is really cool. My API will pre-render the page, and so my SPA and my API need to live together on one server. Now, this is perfect if I have a server-rendered framework like Next.js, Nuxt, or Universal. I can do it in other languages, but because my client-side, my Progressive Web App frameworks are usually JavaScript, then these definitely work best with JavaScript servers. It's great if SEO is my primary goal, and it's great for performance, because I've already got that content rendered by the time my first page loads. On the downside, it's difficult to use other web servers. If I have my .NET backend, for example, then I need to do a whole lot of proxying back and forth between .NET and JavaScript to make this happen. And a lot of these frameworks generally don't use the standard SPA CLIs. So if you really want to keep up with the Angular CLI or the Vue CLI, then you may need to step away from that to be able to do server rendered content. You'll need the version that is both compatible with the CLI and with your backend framework. So a server rendered SPA is great when you need search engine optimization, when you don't want to keep up with the SPA technologies, and you have a compatible backend, usually Node. So we took a look at these 3 solutions and then the bonus one, where we have 2 containers in a single domain, 1 container in a single domain, and 2 containers in 2 different domains. We first looked at 1 container in a single domain where we had both the SPA and the API we had the SPA in the API's public folder. When we looked at 2 containers on subdomains, then we needed to do all of the CORS header and base URL content. When we looked at 2 containers on a single domain, we used the Kubernetes ingress controller to be able to control the content moving in both directions. So which one is best? Well, it depends. And it depends specifically on the task that you're trying to accomplish. When would I use the 1 container, 1 domain? When I have few microservices and I have 1 shared hosting account, I can deploy all the things in one place. When would I use 2 containers with subdomains? When I have very different teams that need to operate on the front end and the back end separately. When would I use 2 containers on a single domain? When I have lots of microservices that dictate the need for the complexity of Kubernetes environment. And so I can spread out my microservices across Kubernetes and scale the pods separately to be able to accomplish the scaling and availability needs of my application. This has been a lot of fun getting to show you how to get past that Docker 101 talk to be able to scale both the progressive web app and the backend API together inside containers. This has been really fun getting to show you these things. If you're watching this later, hit me up on Twitter at Rob_Rich. Or if you're looking for the slides, go to robrich.org. You can get both the slides and the code on robrich.org right now. For those of us who are here live at this event, what are your questions? What are your thoughts? Which solution have you used?
Okay, so yeah, if you do have questions, leave them down in the comment section right now. Maybe some of them are still processing everything right now. Yeah, but actually some of the examples you gave are actually, they're really used. But like one of probably the rarest I've heard was the 2 containers, 1 domain. Because typically they would do like separate domains and then like a separate container for each.
Right. A lot of people do like to put it on 2 separate domains just because then they don't have to mess with the ingress controller. But now you have to do CORS headers and all of the base URL pieces, and that level of complexity can be somewhat overwhelming sometimes.
Yeah, so maybe like it's like if your choice is, if you're like, what do you call that? If you're good with like coding rather than orchestrating, you could choose like the other one, right?
Right.
Or if you're good with the orchestrating part, maybe you could go the other route. Is that right?
Yeah. And it does make the code simpler. So, that is your choice of would you rather the complexity in the code or in the orchestration?
Okay, so there are some questions here on the stream. First is it possible to run CRC on a Docker? That's from Pojong Martinez.
Is it possible to run CRC? I'm not familiar with that acronym. What does CRC stand for?
Okay, so if you can clear that, Pojong, we can ask that. But for now,
yeah, great question. Thanks for asking.
He also has a question. What's the difference between OpenShift and Docker?
Ooh, good question. OpenShift is built on top of Kubernetes, and it gives you some additional administration tools. In particular, you have a UI for being able to create the containers and orchestrate them together, where with regular Kubernetes, you're probably running from YAML files and on the command line. So OpenShift is that nice user experience, but it's still Kubernetes under the hood. Kubernetes will run containers just like Docker Swarm can. And so I like to think of it as this. Docker is the best tool for building containers in development. And Kubernetes is that tool for running those containers at scale. OpenShift then is a different brand of Kubernetes that gives you some additional administration tools. That was a brilliant question. Thank you.
Is it like Kubeflow, but for like a different use case?
Yeah, OpenShift is a variant of Kubernetes.
I see. So
They
John
hide
said,
that fact nicely, but it is.
yeah. So he said that it's the code-ready container. If you're familiar with that.
I didn't hear that very well. Code ready what?
Code-ready container.
Code ready container. Ooh, yes. I've not built code ready containers. I guess we kind of just did, ours were ready to go here, but that's interesting. I have some homework to do.
Okay, so if you do have questions, leave them down here. I guess they're still pretty overwhelmed with that, since most of our
Yes.
viewers are actually, really new. That's why when we ran the poll, they really would like to know the basics. So
Right.
maybe they're still like, because typically here, it's pretty rare still to use containers in deployment.
Mhm.
So yeah, it's slowly
Yeah.
becoming more common here. And it's actually good that we start the conversation so that they could,
Right.
because in real world, we really use that, especially for like large scale applications, right?
And it does make deployment so much easier. All of the concepts of like, did we patch our server and what else is running on the server that might conflict with this? All of those just kind of melt away when we start using containers.
Yeah. Pojong also has another question. How about Vagrant and Docker?
Ooh, good call. Vagrant and Docker, that's a really fun comparison. Vagrant is great for creating virtual machines from code. And so as opposed to Docker, which is great at creating containers from code. If you have a virtual machine, you're virtualizing the hardware. So as you're configuring your Vagrant VM, you'll give it the amount of RAM and CPU and what hard drives and SCSI details that you might have, network configuration details. And that's great for spinning up a virtual machine. You can now RDP or SSH into it and continue configuring it. Ideally, you're moving that configuration into your Vagrant file to be able to spin up the VM pre-built with all the things. By comparison, Docker is that configuration as code file as well. So a Vagrant file and a Dockerfile are very similar, where a Dockerfile will then build a container that is virtualizing the operating system. So the runtime package in a Docker file is a lot lighter weight than with a Vagrant file. But ultimately, it's that same configuration as code mechanism that gets you to repeatable infrastructure in really elegant ways. If you need to scaffold out or consistently build up a virtual machine, Vagrant or Terraform is a really good choice. If you need to do that with containers, Dockerfiles are a great choice.
Okay, so if you do have questions, you can still leave them down here. But okay, so let's just wait for a while. But let's read some shout outs first while we wait. So this is from Rets Gutierrez. He says good evening. And also from Tristan, good evening as well. So I forgot to introduce to you some of the people from our team. Meet Michael and also Maclem. Can you say hi? Like,
Hello.
Hi.
Hello.
why are you so shy? Nahiya kayo.
Hello. Nice
My
meeting
brain
you.
is leaking out of my ear because all of the coolness.
Yeah. Mhm.
Yeah, you have
France,
a very
yeah.
topic.
Yeah, Franz said that cool topic and
Shout
very
out.
insightful. Yeah,
I'm so glad you enjoyed it.
yeah. Actually, this is like the best. This got the highest vote in the poll. So they're really
Ooh.
interested, but maybe they're still looking for resources on this. So like, probably if they're new about this, like, where's the best place to start? Especially with like containerization and everything.
The best place to start is to start trying to build up some Docker files to be able to grab the content that you need and run it in containers. Kubernetes and Docker Swarm, Docker Compose are probably overkill when you're just beginning. Just start messing with Dockerfiles. And the cool part is you can find a lot of Dockerfiles online and just copy and paste them into place and then start futzing with them, tweaking them, adjusting them to your needs. And at that point, when you get to that level of confidence with Dockerfiles, then you can start creating your own and build up these containers. The Docker build and Docker run commands are really straightforward. And so you can get at that content in a really elegant way as well. Get started playing with building Dockerfiles. And as you get comfortable, then start layering in concepts like Docker Compose and Kubernetes.
Okay, so yeah, for them, yeah, it's really super advanced, but they really liked it. Maybe like, just by watching, like it sparked their their idea to actually start learning. Okay, here's a question from Ritz. It's my first time to hear about Docker. Is it possible to use and apply in different web programming language, such as ASPX or PHP?
Yes. In this case, we built a .NET, ASP.NET backend, but we could definitely build a Node backend or a PHP backend. We would just include in our Dockerfile the base image that includes those tools and also the details associated with that server. So let's flip over to our Dockerfile that we built for .NET, and let's customize it for PHP. Now, in this case, we chose to build from this base image, but if we flip over to Docker Hub and search for PHP, then we can see that there is a PHP base container. And so here's the supported architectures. That's pretty cool. And here is the tags available to us. Is there an Alpine variant? Ooh, there is. FPM Alpine. So I would build this Dockerfile like this. From PHP FPM Alpine, copy in all of my content. In this case, I probably don't need to do that. And then I would say run Perl restore if we have some libraries. And then PHP is interpreted rather than compiled, so I don't need all of this thing. And then I would say PHP my app.php. So a Docker file for PHP is actually quite a bit simpler. I might need to set some environment variables about what port I want to run on. But there we go. Great question.
Yeah, like the good thing about Docker is that there's a really big community behind it. Like if you want to, like when you have a specific use case, just go search for it. Then most likely there's like a certain, like there's an Alpine for it. You could choose your preferred language, and there's it already.
Yeah, and this works exactly the same for Java or for Ruby or for Go or any of the server languages. You can just build up this Docker file that will get you from your source code to that running container, and then build and run that inside of Docker, and you've got your API ready to go.
Yeah. Pojong says that GitHub Workflows uses Docker.
Yes. GitHub Actions is amazing. I have another talk, and I would love to come back to the group maybe and do a talk using GitHub Actions. It's really fun.
Yeah, actually, we use that GitHub Actions to like when we push to master, it would automatically build it for us and deploy it.
Exactly.
That's really cool. So, like, it's kind of lazy, but it's actually really slick, right? you just put what you want to do. It's just there when you think about it. Yeah. Okay, so I guess if you don't have any other questions, I guess that's it. Thank you for sharing your knowledge to our community, and definitely welcome to the Philippines again.
Most definitely. It's been so much fun being in Manila for the day.
We hope that we can invite you like once that we can.
Most definitely.
Here.
I didn't hear any chickens in the background though.
Yeah, we're at the urban part of Metro Manila. So,
there we go.
Yeah.
Yeah, I lived around Ormoc, and so I would get to ride the jeepneys with chickens all the time. It was fun.
Yeah. Pojong said specifically using in integration testing.
Ooh, very nice. Containers with integration testing is really, really fun. What's interesting about integration testing is I probably need to configure a very specific browser. I need to configure servers in a very specific way. And what's elegant about Docker is I can do that. I can launch my backend container. I can launch my front-end container. I can configure the database in a very specific way. And then I can launch one more container that is that integration test suite. So maybe it's Cypress running a whole lot of browser tests, or maybe it's Selenium that gets to test drive my website, or maybe I'm just running a bunch of web requests from maybe a Postman script. And I just fire all of the requests from that one container. And then once I'm done, I can kill off that whole environment. And I didn't need to, worry about the various servers that I needed to set up, or if anyone else was using them. I just spin up my own whole environment to be able to do all of that integration testing. Containers are perfect for integration testing.
Okay, so yeah, Tristan said chickens are asleep at night.
There you go.
Yeah. Okay, so it's almost like midnight here, so maybe we want to rest. So with that, yeah, so hopefully we can invite you to go here. We will surely make it happen. And
that sounds perfect.
Yeah. So before
and thanks for staying up late with us.
Yeah. Oh, Tristan said that he followed you on Twitter. So.
Oh, perfect. Thank you.
Okay, so before we end, we typically do our I guess I need to ask any tips for web developers in general?
Any tips for web developers? A lot of things that we explored today may be new to you, and that's totally fine. There's nothing magic about anything I presented today. I was sitting in your shoes not that long ago. This is what's really fun. The next step is yours. You get to experience this, learn this concept, and get to be an expert in this as well. If you found this really fun, reach out to me on Twitter and I can help you get to the next step, or just start experimenting. You're going to have a lot of fun with this. You got it.
Wow, that's a really great tip. Before we end, we usually take a pic. Oh, Pojong said that thank you for sharing your knowledge.
You're welcome.
So we take a picture, but instead of just taking a picture, what we do is we point our fingers towards where the middle is. So at the center, yeah. Oh, so we feel like we're connected, yeah. Even though we're so far away. Okay, so who will take the picture?
Okay, I'll do the taking picture.
Okay.
Wait, for a while.
That is so fun.
Di kahit mag-post na lang tayo.
Yeah, I guess that's okay already. We'll just take a
Just
screenshot of
screenshot
what
na
we
lang
did, and then we'll like upload it.
Hmm.
So yeah, we
Ready?
usually do it because no, it's already done. It's already done,
Ano na?
right? Or we have to do it
Did we
again.
get it?
Anyway, let's just do it again.
Okay.
Okay, sige.
Okay.
1,
1, 2, 3.
2, 3. Okay. Okay.
Yeah.
Yeah, that's good.
Yeah. Okay.
That's cool. I want to tweet that picture. Send it to me, and that'll be really fun.
Yeah.
Sure.
We'll send it.
Send him the picture.
So,
After this.
right, we felt like even though we're far away from each other, you feel like
Yep, we're still connected
somehow. Yeah.
I hope Rob
Okay, with that,
personally soon, huh? Come to the Philippines soon, Rob, and we will enjoy.
Yeah. We will tour like different food places.
Ooh, that sounds like fun.
Yeah. When everything gets back to normal, hopefully.
Yeah, hopefully.
Yes.
We'll go back to normal.
Anyway, that's it. We're not gonna keep you longer. So once again, thank you, Sir Rob, and definitely we will invite you in the future. Thank
Sounds
you
great.
for your time.
Magandang gabi and maayong gabi.
Maayong gabi. Okay, so before we end the show, I will just be showing some slides before we end. So if you missed this talk and you wanted to watch it again, if you want to, get back to that demonstration again, you can watch it on our PWA Pilipinas app. You can visit it at app.pwapilipinas.org. It's also on Google Play, and if you have a Windows desktop, you can get it via the Microsoft Store. We're on Facebook, Twitter, LinkedIn, email. We also have our website at pwapilipinas.org. And yeah, instead of showing all of these, I'm just going to show a video. It would be really short. So thank you to our sponsor and partners.
PWA Pilipinas would like to thank the following sponsors: Amazon Web Services, Apper.ph, community partners: Algo Filipino, Omniquotient, Angel Hack, React.js Philippines, Google Developer Student Club AMA Computer College Caloocan, Angular Philippines, Phil IT Org, Computer Professionals Union. Maraming salamat!
Okay. Thank you to everyone that watched that video. So, volunteers, if you want to volunteer, send us an email. For our partners, Omniquotient, if you want to share or ask questions, there's a community for developers at Omniquotient. New Energy Nexus Hackathon, the details are on our Facebook page. Oh, this is already done. So, build the modern data app. That's happening on September 3rd, 2021. Just visit bit.ly/PWA-Pilipinas-PH. We also have Space Apps Challenge happening October 2 to 3. Just visit spaceapps.co and register. We also have the PWA Summit happening on October 6 and 7. And that's it. We want your feedback. So visit this bit.ly/PWA-form. So if you wanted to win a shirt, if you wanted to win the shirt, so fill up that form, and we will have another draw tomorrow. So yeah, so congratulations to the winners of those shirts from the previous raffles. So once again, I'm Adesito de Guzman of PWA Pilipinas.
My name is Michael Lance.
And
Maclev.
I'm M. Adan.
And I'm Rob Richardson in Phoenix, Arizona.
And we are
PWA Pilipinas.
PWA Pilipinas.
So we will be leaving you a video from AWS as a thank you for their prize. So with that, bye.
Bye-bye and
Good
see
night.
you soon.
Bye-bye.
Good night.
Goodbye.
AWS is the world's most comprehensive and broadly adopted cloud platform. Millions of customers trust AWS to power their infrastructure and applications. Organizations of every type and size are using AWS to lower costs, become more agile, and innovate faster. AWS provides on-demand delivery of technology services via the internet with pay-as-you-go pricing. You can use these services to build and run virtually any type of application without upfront costs or ongoing commitments. You only pay for what you use. AWS gives you more services and more features within those services than any other cloud provider. This makes it faster, easier, and more cost-effective to move your existing applications to the cloud and to build anything you can imagine. From infrastructure technologies like compute, storage, and databases, to emerging technologies such as machine learning and artificial intelligence, data lakes and analytics, and Internet of Things. Building on AWS means you can choose the right tool for the job. For example, AWS offers the widest variety of databases that are purpose-built for different types of applications. With AWS, you can leverage the latest technologies to experiment and innovate more quickly. We are continually accelerating our pace of innovation to invent entirely new technologies you can use to transform your business. Like pioneering the serverless computing space with the launch of AWS Lambda, which lets developers run their code without provisioning or managing servers. And AWS built Amazon SageMaker, a fully managed machine learning service that empowers everyday developers and scientists to use machine learning without any previous experience. We are constantly expanding our global network of AWS regions, so you can access AWS services to build and run your applications from anywhere in the world. Each of these regions has multiple availability zones that are physically separated from each other and connected by low latency, high throughput, and highly redundant networking. This makes it easy to design and operate applications that are scalable, fault-tolerant, and highly available. Our infrastructure is built to satisfy the security standards of the most risk-sensitive organizations. You also have access to the AWS Partner Network, which has thousands of systems integrators who specialize in AWS services, and tens of thousands of independent software vendors who adapt their technology to work on AWS. With the largest community of customers across every industry, AWS has unmatched experience and operational expertise you can depend upon for your most important applications and every imaginable use case.